One important feature for microcontrollers is serial communication, and in the STM32 module, this is handled by UART units. Now let's talk briefly about the difference between UART and UART. UART stands for Universal Asynchronous Receiver Transmitter. It works without a clock signal. This makes it simple and ideal for basic communication with devices like a PC, GPS modules, or Bluetooth modules. It uses only two wires, TX for transmit and RX for receive. UART, on the other hand, stands for Universal Synchronous Asynchronous Receiver Transmitter. It supports both asynchronous communication just like UART and also synchronous communication, where a clock line is used for higher speed and better timing control. The STM32 microcontroller includes three UART units: UART 1, UART 2, and UART 3, and all of them can be used as UARTs for asynchronous serial communication. In this project, we will learn how to use at least one of these units. This video is sponsored by PCBWay. They have got some awesome deals for September that you don't wanna miss. From September 1st to 30th, you can get PCBWay's beautiful purple solder mask absolutely free. It's a great way to give your PCBs a clean, vibrant look without spending a cent extra. Also this month, TPU 3D printing using FDM is up to 80% off. If you are working on flexible parts or prototypes, this is the perfect time to give it a try at the huge discount. And don't forget, PCBWay's 8th project design contest is now live. It's a great chance to share your projects with the community and maybe even win some prizes. Links are in the description, go check them out. In the first part where I talked about the STM32 microcontroller, I mentioned that the USB port is only used to power the module and cannot be used for the communication with the computer. Therefore, alongside the STM32 microcontroller, I will use an Arduino as an interface between the computer and the STM32 module. In this picture, you can see the two serial communication pins, transmitter and receiver on the STM32 module. One important thing to keep in mind is that if these pins are connected directly to the Arduino, there is a risk of damaging the STM32 due to voltage differences. So I connect the STM32 receiver pin to the output of a voltage divider to safely lower the voltage. Next, I assign 3 pins as outputs which I plan to connect to several LEDs. Now it's time to open a new Arduino project. Check the serial settings and identify the type of microcontroller. I use a pre-written program that receives data as integers and controls the output pins accordingly. Keep in mind, to properly receive the data, we need to write this command 4 times. The last number is a dummy value. If you get errors in the program, try changing the microcontroller type in your settings. After extracting the hex file, I use the STM32 utility software along with a programmer to flash the microcontroller. Once the LEDs were connected, I no longer needed to do anything else with the STM32 itself. Now it's time to program the Arduino. On the Arduino side, I'm using the SoftwareSerial library to send data. With the command I wrote, pin 3 acts as the transmitter, which is connected to the input of the voltage divider in the circuit. I will also share you the complete circuit diagram. In the Arduino code, I've written commands that receive the data from the physical serial interface and then send it to the STM32 in the same format. I tested several times and it worked perfectly. Now I've added a few conditional commands to the STM32 program that report which LEDs are currently on. On the Arduino side, these messages are received using the SoftwareSerial library and then displayed in the serial monitor. Alright, let's test it out. Now all the LEDs are off and yeah, it's working just fine. If you enter invalid value, it will actually report that the received data is invalid. I also had an STM32 microcontroller from the F0 series, and I was like, can I get this one to work too? Well, I spent about 2 hours trying to connect to it, and guess what? Nothing. It just wouldn't respond. No connection, nothing happened in the end. I'll keep working on it to figure out what the issue is, and if I manage to get it working, I will share the result with you in a short video. Anyway, thank you for watching. Don't forget to like, comment, and subscribe. See you next time. Bye bye.